All right, number 6, we have another system of 2, and it says substitution, but again, I would not recommend substitution in this form, only when x is 1 or y is 1, and it's easy to solve for the other. In this case, it's going to be better to do elimination. So we're going to do elimination as well here. Negative 3x minus 5y equals 14. And then 12x plus 20y equals negative 55. Okay, so this time we're going to eliminate x, smaller number to deal with. If we multiply by 4, it will be 12, and then they will already be opposite. So I don't even have to manipulate the second equation. So I'm going to write the second equation down. 20y equals negative 55. And I'm going to multiply this equation by 4. Multiply everything by 4. So when I multiply by 4, I get negative 12x. Multiply by 4, I get negative 20y. Multiply by 4, and we get 54. No, 56. 16, yes, 56. Okay, combine these, we get 0. That gets eliminated. Okay, the y also gets eliminated, and then we're left with positive 1. So 0 equals 1 is not a true statement. This is false. So that means we are not going to get a solution. That means these are parallel lines, and they will not intersect. Okay, so here, instead of one solution, we're going to have inconsistent. It means we're not going to get a solution at all. Oh, I hit skip, but that should have been correct. We'll go ahead and do number 7 here. Again, we will use elimination. That'll be easier to do. Negative 2x plus 3y equals 20. And then we have 10x minus 15y equals negative 100. We're going to multiply and get rid of x again. Just multiplying by 5 will get us the opposite sign with the same number. So my 10x minus 15y equals negative 100. Multiply by 5 and we get negative 10x. Multiply by 5 we get 15y. Multiply by 5 we get 100. 5 times 20 is 100. Okay, here, this is opposite, it goes to 0. This is opposite, it goes to 0. This is opposite, it goes to 0. This time, everything canceled out. This is a true statement. So what happens, it means that these equations are exactly the same. If everything goes to 0 and then you end up with 0, then these equations are the same. So we're going to say this is a dependent system. And the input, I think, we just solved for y. So I'm going to take one of these and I'm going to solve for y. This is the first one. Negative 2x plus 3y equals 20. And if I solve for y, subtract or add 2x, we get 3y equals 2x plus 20. Divide by 3. And we get y equals 2 divided by 3x, and then plus 20 divided by 3. Now, since x is usually the independent variable, we're going to put the x here. So x is going to be itself. The y is equal to this equation. So y is equal to 2 divided by 3x, and then plus 20 divided by 3. So you just type that as the equation when you solve for y. And then we say x is any real number because x can be anything. So x is the independent variable. But basically when you get dependent, we just say there's really infinitely many solutions. Usually we used to say infinitely many solutions. So any there's a bunch of ordered pairs that will work, basically. So now instead of saying infinitely many solutions, we'll give you the equation and saying that x can be any number that you want, and when you plug in a number for x, you'll get a y value, and that will give you the infinitely many solutions. But this is how we say that. X are independent, y equals, when you solve it for y, you get the equation, and you put that for y, and we say x can be any real number.